What's going on, faithful YouTube subscribers? It's me, your favorite dynamics instructor, Dean. Today we're going to be talking a little bit about Chapter 3, Inertial Response of Translating Bodies. We're just going to run through an example problem using this tennis ball. This tennis ball is going to be representative of an airplane, and since I am not yet rich, I do not have an airplane with me. So we're just going to use this as an example. A little bit of background. Tennis ball weighs about 0.125 pounds. We're going to say that this is a massless line. I connected some fishing line to this. We're going to say that the radius of this is about 1 foot, and the velocity is about 1 foot per second when we rotate it in a circle like this. So as you can see, this is going around, and we want to determine the speed of the ball or the airplane in this at the starting point after 3 seconds. So you can see it's going around. We're going to have a thrust of 1 Newton, which translates to about 0.2248 pound force. Okay, so now that we have a few givens in our problem, like I said, we want to determine the speed of the ball at the starting point after t equals 3 seconds. Right here I have my free body diagram drawn, and this is the first equation we're going to be looking at. This equation is actually given in 3.52 of our book. It's directly applicable to what we're going to be doing, and this is going to simplify down to this that you see right here. So you can see we have 3 seconds in for our time, and then we have our integral from 0 to 3 seconds. The initial speed, as I already mentioned, says here 1 meter per second. That should be 1 foot per second. So that we have this here, we have the weight of the ball, or the airplane, 1 foot for the radius, and 1 foot per second for our velocity. When you multiply this, obviously it's 0.125 times 1 times 1. It's going to be 0.125 pound-feet squared per second. Then we're going to put the two equations together. That's this right here. So we have h 3 seconds is what we just found, plus 1 foot times 0.2248 pound force, which, as I said, is equal to 1 Newton, multiplied by the time, 3 seconds. That's going to equal 0.7994 pound-feet squared per second. And I have written here that the magnitude of the angular momentum is equal to rmv theta, which can be expressed in terms of the angular velocity. By utilizing r theta equal to r angular velocity to get h equal r squared m angular velocity. So by using this, we can see that h, which is this value we found, equal to 1 meter squared, should be 1 foot squared, I apologize for that, times 0.125 times the angular momentum. We can solve this very easily. Just take these two numbers, divide them over. We get that the angular velocity is equal to 6.395 radians per second. And we can actually resort to linear momentum to check our result. So I hope this helps. Just a quick problem looking at angular momentum and angular impulse. Please like, comment, and subscribe to see more content. I am trying to become a famous YouTube creator. I really hope you guys enjoyed. Thank you, Dr. Campbell.